dilation. So in time dilation, when we talk about time dilation, so what we can say is that a certain person, he is moving at a certain speed, but that speed is closer to speed of light. In short, c. So if the person is speeding or is moving at closer to speed of light, he will experience time dilation. Second, if you are in a stronger magnetic or stronger gravitational field, you will experience a more time dilation. Gravitational field also causes time dilation. Okay, so, and I think it is the best example if we have is the, or is that this? No, we wouldn't do that. Okay, so then we can also talk about, we could also talk about, yeah, the formula itself. When we talk about the formula of time dilation, this equals gamma. The this quantity is gamma. It's called time dilation factor, gamma factor. Okay, when I talk about that what it is, c is the speed of light. C is the speed of light. V is speed which the person or that whatever that object is traveling near the speed of light, and let's suppose whatever that value is, it should be 0.8, or let's suppose this is 0.8 c. So when we apply this in this, what we get, 1 minus 0 1 c over this square, 1 minus 0.8 c over c square. What happens? These two cancel each other, so we get 1 minus 0.8. So c cancel each other. C square and c over c square equal 1. Okay. Then we talk about, okay, when we study this formula closer look at this, what we get, 1 over this 1 minus a value, and 1 minus a value, and it's that's 1 which is 0. Let's suppose 0.8 or 0.9. That value, square root of that value is something closer to speed 0, something closer to 0, and that something closer to 0 divided by divided divided by 1 equal huge number or huge numbers. Okay, and if I want to give an example for this, I would say 0.8 c. What is it in gamma? 5 by 3, and it is 1.67 years. And what I mean by 1.67 years is that 1 year, because this is, we take this one, if I write the formula, it is actually time with respect to the person divided by the speed. Person watch clock time. Okay, so this means 1 year, not person's time, this is the one stationary observer time. So this shows that 1 year on on Earth is one, not on Earth, on on that ship is 1.667 years on Earth. So it's opposite. Sorry, I was wrong. 1 year of that uh, traveling object is sorry, is 1.67 years on Earth. So in terms of stationary, like let's suppose if I illustrate it, or if I make a diagram for it, what I will say, the person is on this over here, and this is the traveling person. So for him, when 1 year has passed, for this guy 1.67 years have passed. So he is behind time. Oh, sorry, ahead of time, and he is behind time. But for them, it's the same in their perspective, but different in each other's perspective. So here we talk about perspective, respect to observer. And when I talk about 1.67 years and one year, I say that for the person who is traveling, for person who is traveling with value, whatever the value, c, or when we have already taken the value 0.8 c, right, we have taken 0.8 c, yes, with 0.8 c, for him the time duration is 1 year for him and 1.67 years for the Earth observer, according to the traveler. So what I mean by this, that according to the observer, we always talk about observer, because when we talk about difference in time, different observers experience different time gap. So we have to be careful on whose perspective we are talking about, because when we look at this in a way that when he is measuring, he is moving this way, what he's seeing that this person is going away from him. Okay, when he's going this direction, what he's saying is that the one who is on Earth is going far and far away from him. So that's why we talk about the perspective. And if we would say the same thing for the Earth observer as well. He is stationary, and what's happening is that this person is going away from him. So when Earth observer is stationary, the one who's traveling is going away, and when for him he is stationary, he's moving but he's stationary according to where he is in his own ship. So for him, this Earth traveler is going away, or Earth person is going away. Okay, so we could take more examples as well for the values. 0.9 c would result in 0.9 c would result in 10 power square root 19 over 19. Okay, this value, and it is 2.24, and so on. We could take many examples, but always remember, an object with mass just this color. An object with mass will never, when I say never, it's never reach exact the speed of light or exceed that speed of light. Okay? So this is the limit. As what are the particles which go at the speed of light? Photons. And what we know about photons? Photons are massless particles. Massless particles. That's why that is what light is. They have that value. But anything which has mass will only be able to reach 0.99, sorry, not 99.9% the speed of light. 99% speed of light, or let's make it more better. It will never exceed that 0.1. It will never exceed it. It's impossible. So limit is v a approaching the speed of light is always less than c. This is our inequality. Okay, this can be seen through E equal mc square. It shows that E over m equals c square. The more, and we could also study this, but this is not according to our topic. This is not for our topic. Just remember that anything with speed of light will never, with mass will never reach the speed of light. Okay, so then when we talk about what else do we talk about? Yeah, let's take an example for the time dilation. Okay, the example for time dilation. Let's suppose we take my example, my age. Or yeah, we take that me and my friend, we both have 17 years. That I'm 17 right now, so 17 for me, and same for my other guy, 17. We both have 17 right now. And what happens that we both take a journey. Not we both, one of us will take a journey. And let's say it's me. I will go. 17 age. Okay. So what I'm supposed to do here, I'm going out into space. Let's suppose I travel 10 light years. I travel 10 light years. Okay. When I'm traveling 10 light years, so how will this, and my friend is stationary on Earth. This is me, and this is a friend. Okay. So what will happen for me? For first of all, for my friend. For him, t will equal 10 over the speed. Let's suppose I'm traveling at 0.8 the speed of light. Okay, this is my v. Okay, so what will he experience? The time he will experience is 10 over 8, which is 10 over 0.8, which is, so for him 12.5 years will pass as I'm going away from him. Plus if I do a return journey, that would be times 2, so 25 years. So in total, when I go out into space and come back to Earth, for the Earth observer, he's Earth observer, for him 25 years would have passed time. Okay. Plus, okay, now when we talk about my time, how much time I experienced, it would be, take gamma of 0.8, which is 5 by 3, and this equals to 1.67 years. Okay. Now, the formula for my time calculation is time I 17 equal time friend over gamma. and time friend is 25 over gamma, which is 5 by 3. Okay, so what do we get? We get 15 years. So that means 25 years on Earth for my friend is 15 years for me since I traveled out into space and returned back. So then this could be said as, and I do it when I'm returned back. Okay, first of all, let's see what's the age gap. Age. This is our summary. Age gap. What is our age gap? Our age gap is 17 plus 25 age friend, and it will be 17 plus 25, which is 42 years. So my friend will be 42 years, and what will be my age? My age is 17 plus 15, and this means I am 32 years. So we both who are at the same age right now, and I was supposed to go to space. I were to go to space. My age would come out to be 10 years less than. Look, the difference of 10 years difference. So 10-year difference. Those who started at the same age ended up being 10 years smaller than one another, and which that's me. I'm the one who is smaller than the other person. So then what could we say? In conclusion, wait, one more thing. We also talked about the, what do we talk about? Yeah, over here. We talked about this gravitational field also affects or causes time dilation. When you're near a stronger field, stronger what do you call that, gravitational field. And what has a stronger gravitational field? One and only black hole. Okay, one and only black hole. If the moment you reach its event horizon, event horizon, event horizon, there's no turning. Even if you don't, if you get a little closer to it, you will start experiencing uh, the force or the gravitational strength. And that strength, what it does, it let's suppose there's a light beam which is traveling over here, it's traveling like this. Because of it reaching the black hole and the gravitational field of black hole being dense, the light will curve. It will act like this. This can be can be also same as time dilation, time dilation, distortion, distortion.